All right, thank you. So yeah, I'll be presenting on the Missouri Winter Severity Index. And next slide. So traditionally, winter severity index have usually been developed to quantify how much precipitation you have, and not just that, but also what are the societal impacts of that of the storm. Next slide. Most states have, especially those who are affected by snow, have some form of winter severity indices, but the majority of them are basically based on precipitation, how much snow you have, how much freezing rain. It's based on the weather. A few, I think, the blue states try to incorporate some accident rates into their indices, but generally, we primarily focus on the extent of the weather event. Next slide. So this is how why Missouri wanted to try to find a different way to compute our severity index. Currently, our measure of performance was basically how long it took us to clear the roads. That was pretty much how we measured the performance, how we performed. But that was a little bit subjective, and sometimes it's just challenging to put that burden on the maintenance crew to do that. So we try to come up with a measure that is dependent, is data driven, first of all, and we are not just looking at the weather, but we're also looking at how much money we paid, what is the impact on mobility, and then also the safety component. Next slide. The challenge with this, though, is that you need data to be able to do this. So there are different data sets that you will need to put together to come up with a WSI that captures not just the weather, but also you're looking at safety and mobility. So we have all these four data sets that we needed. And not just that, you also have to make sure you connect them. They are all connected. And so that was one challenge that comes with trying to put together a WSI based on this. Next. So to overcome this challenge, we centralized the data, and then we found a way to integrate all of them in one place. Next slide. So just so you know what kind of data we pull in. So for the weather data, we're looking at snow depths, freezing rain, sleets. The National Weather Service has shown, has proven to be the best source of data for us. We also use some third-party data, but especially with our recent events, we noticed there were some discrepancies. It wasn't able to estimate the snow depths very well. It's able to get exactly when, the timing of the snow, it's usually good, but like the snow amounts were not as accurate compared to National Weather Service. So we generally use the National Weather Service data to basically quantify the amount. And then the third party right now, we just use it to figure out when it started and when it ended. Next slide. And then also we kind of use the National Weather Service categories to categorize the different weather events into minor impacts, moderate impacts, just according to the National Weather Service categories. Next slide. And then for maintenance, we mainly looking at costs. How much did it cost us? So we're looking at fringes, labor costs, treatment costs, and all this data is captured right now by our Missouri MMS, the Maintenance Management System, which basically puts all this data together, and we get to use it to compute our WSI. Next slide. And this is just an example to show the cost varies. Like we have different costs for snow, and then when it's just freezing rain. So this data is captured, and that is incorporated into our WSI computations. Next slide. So for safety, we are mostly concerned about the severity of the crash. So not all crashes are the same. So some are just PDO, some are minor injuries, some are fatalities, unfortunately. And so we needed to know for each crash what was the severity of the crash. Now that creates some complexities because if you want near real-time data, you may not be able to get it because, especially for fatalities, sometimes it doesn't happen at a crash. It happens in the hospital, and it takes time to get that data in. But to be able to supplement that data, we also don't only rely on highway patrol data. we kind of use the TMC data and the WAIS data to kind of supplement some of the data that we don't have. Next slide. So that's just an example of basically crashes in Missouri. Next slide. So mobility is another component. So the data is usually we're just computing, looking at congestion across the state. And this data is coming from here. We get that in real time. So we're able to compute this as the snow event goes on. Next slide. Okay, so that's just an example of basically the coverage we have across the state of road segments that we can pull the probe data or so this is the probe data is generally travel time data and speeds. So for every road segment, we have the speeds. I think this comes in every minute, and we're able to aggregate it and compute where the congestion is happening during the snowstorm. Next slide. So once we know we have all our data sets, the most important thing is to join all of them together. In Missouri, we have what we called maintenance facility regions or buildings. And what you're seeing on your screen is basically each of the regions, the area that they cover. And so we use this as our foundation, and then we connect all the data sets to this region, this layer. So next, we can then bring in the crash data, connect to every maintenance facility so that when there is snow, we can know for each facility region, we can know how many crashes happened in each region next. So we can also pull in the probe data the same way, and then the weather data, which comes next, can also be integrated. So this is the first and most important step before we actually go into the developing the WSI. Next slide. So once we have connected everything, you will have, we have a table like this where you can have for each date, we know for each district and each building facility or code, we know what the snow category was, how much it cost us, how many crashes we had, how many miles of roads were congested. We kind of have come up with something like this after the conflation. Next slide. Now, so to develop the WSI, we had two questions we wanted to solve. Whenever there's an event, we want to know whether there was an impact. Now, if there's an impact, we are talking about, was there an impact on safety? Was there an impact of mobility and cost? And then the next question, which is the next, is we're looking at, if you can go to the next, we're looking at if there was an impact, how does it compare to our baseline? Okay, so we have baseline events, we have some key events, some big storms that we've gone through the past, and we noticed, okay, this demanded a lot of response. These are our biggest, these are our base. We're going to use that as our baseline and compare every other storm to those storms that we know. And so these are the two steps we used to come up with our WSI. Next slide. Okay, so for crashes, if we want to know that whether we have an impact or not, we follow these three steps. We compute what we call PDO equivalent crashes. So PDO is property damages only. We compute the PDO equivalent crashes, and I'll explain what equivalent crashes mean in the next slide. But what we do is the first step, we compute the PDO equivalent crashes during the event, and then we go back 1 week on the same day. If there was no winter event, we compute the PDO equivalent crashes for that same day. And then we basically calculate what's the difference in the number of crashes. Okay, so there's an event on Tuesday today, to Wednesday today. We look at how many PDO equivalent crashes we have. We go back last week, Wednesday, if there was no winter event, we compute the same PDO equivalent crashes, and then we look at the change in the number of crashes. Next slide. So this is how we come by our PDO equivalent crashes. We're given, so Missouri have costs for each severity of crashes. So for fatal crashes, we're looking at 11 million, 11.6 million. And for serious crashes, just under a million. And then we do have these costs for each of the crash severities. And then what we do is we divide all of them by the PDO crash. So PDO, property damage only. And so in this case, once we do the division, the last column is telling you the PDO equivalent. So a fatal crash in this case is the same as having 947 PDO crashes. Okay, so if you had just one crash during the storm and it was fatal, we are going to count that as 947 PDO crashes in our WSI. Next slide. So that was it for safety. For mobility, we basically look at the 85th percentile of the speeds for each segment. That's our indication of congestion. And then we sum up all the miles, the roads that were congested within the particular facility, maintenance facility. So it will be the sum of all the congested miles during the event. That's what gives us the measure of mobility impact. And so the same way we do it during the event, and then we go back 1 week, and then we compare it to on a non-weather event day, what was the congested miles? Next slide. Okay, so once we know what the impact is, we want to compare it to a baseline. And so now that helps us to compare. We compare it to a baseline so that we will know, okay, how did we do compared to these big baselines. So the baselines we had, these are well-known events that happen through Missouri. We use them as our baseline. So every event is compared to these six events. And so if you get a value that is greater than 1, that means that whatever event we had was actually more impactful than any of these events. And so in the same way, we'll calculate the number of PDO crashes if it's for crashes for these events, and then we compare it to the event we are having. Next. Okay, so basically, if we have a WSI that's less than 1, what it's meaning is that the snowstorm we're having was below the average impact of these baseline events. If we get a WSI that's greater than 1 for any slow event, then it means that we have an event that was above the average for these for these 6 events. Next slide. Now, we're trying to have another way of looking at the baseline, because the baselines we used in the previous slide, now while the snow event was big, it covered most of the states, the amount of snow varied a lot. So some facilities had like 2 inches of snow and some had like 12 inches of snow. So even though there were big events, the amount of snow varied a lot. So we are also now trying to normalize based on the category. So if there's a snowstorm now and it's between 2 to 7 inches, then we are going to normalize it to a similar event, to a similar snow event. And so this is how we kind of categorize our snow events, and we're using these also to kind of as our baseline to normalize the WSI. Next slide. Okay, so in this case, and the WSI that's less than 1 will also mean that the impact of the snowstorm was below average for a particular category. So if it was a category 1 and the WSI was less than 1, that means for category 1 events, that the event we had was less than that, was below the average. Next slide. Okay, so once we've put all this thing together, we put everything into a dashboard. And so you can track things by year, how we're doing. The chart on the left, the blue bars are basically how much the WSI for cost. The red bars are for safety, and the greenish, yellowish bars are for mobility. So it looks like the cost has been maintained 2022, 2023, 2024. It looks like it's not changing much. Safety is also almost not changing much. Looks like mobility dropped 2023 and 2024. So you're able to track these. And then you can also, on the right, I'm showing it by different types of storms. So we can see when there was a major storm, how was the impact on the mobility and safety and all that. It's a dashboard that enables you to do this. Next slide. So this is, I'm just showing parts of the dashboard. There will be a slide that will show everything. But we're also able to put, basically color code all the maintenance facilities by how they did based on the WSI for cost, safety, and mobility at the same time. So sometimes you will see the safety and mobility going together. So there were a lot of crashes, so it slowed things down a lot. And then you can also see, hey, how much did we spend here? We did not spend much. So you're able to kind of interactively look at the data in different dimensions. Next slide. Okay, so generally this is the kind of the outlook of the dashboard. You will have maps that is color coded based on the WSI for cost. And there will also be numbers up there. So those numbers are basically, so for maintenance cost, that's the WSI for cost. Crash cost, that's the WSI for the crashes. And then delay, we have a WSI for the delay also. So a 0.85 maintenance cost WSI means that basically we spend below the average for those big events. 1.77 crash cost means that you basically the event is above the average that we will have for those events, big events. And delay 0.92 is also below the average. Next slide. Okay, so here I selected, so the dashboard is interactive. So just like Iowa, you can select a particular event and look at how it impacted the state. So you can see all the maintenance areas that were responding to the event. And you can also like go down into the maintenance area and look at numbers for those maintenance buildings. But we can see the cost. So in this case, the maintenance cost doubled. Um, and then the crashes also almost doubled. Delay was a little below average. So that's basically the goal of this. It's all automated. All the data sets are connected automatically, and this is updated automatically also. Next slide. So this was one event that happened November 28th and the 30th. Um, there was a storm on, I think it was a Friday and a Saturday. And there was a game. Now, on Saturday, you don't expect so many people to be out, but there was a Kansas City Chiefs game in Kansas City, and then there was a Mizzou football game in Columbia. So, for instance, if you look at the delay map, those two areas which I've read, that I read, it's really in the middle of nowhere. You wouldn't expect delays to be there. But we have Interstate 70 goes through those areas, and people were going either way. Like there were people moving to the Kansas City's game, and then there were people moving to the Mizzou game. And the snowstorm hit, and they still wanted to go watch the game. So there were a lot of crashes. So we'll see a lot of there were fatalities, a lot of fatalities, and it slowed down traffic a lot. And so those particular two buildings had the worst delays and safety issues. So it's basically it helps reflect what was going on. Safety was basically doubled. Delay also was way above the average. We didn't spend much for that snowstorm. In fact, the prediction was that we're only going to get about 1 inch, and we ended up getting about 4 to 5 inches. So it was very reflective of how much we spent and um, what actually happened with the delay and then the cost. Next slide. Okay, I'll turn it over to Paul to summarize this.
Okay, thanks, Dr. Yao. So we started this prior to looking at this WSI for mobility, safety, and operations itself. MoDOT has a tracker system program that we currently use. And in that tracker program, we're measuring things for safety, service, and stability across all departments, across everything that we do. And for us in maintenance, one tracker measure that we have that falls under service is operating a reliable transportation system. And specifically, it was a time to meet winter performance measures. And so Dr. Yao had commented on this before of we were really looking at what was the time that it took us to get our roads back to a clear condition. And we were measuring that from the end of precipitation until those roads got back clear for our major routes and interstates. And then for our lower volume routes, our performance objective was to get them open to two-way traffic. And so it was a little subjective on when building supervisors would see when was the end of the precipitation in their area. And then also when did that road get back to that condition. But one thing that we were always missing is, what was the impact to the public for those? We were measuring what's our time to get these back to clear, but what was the cost? What was the delay cost? What was the safety cost to the public? And so when we teamed up with MU on this research project and we're able to find a way to be able to capture that additional information of what was the cost of this storm to the traveling public in terms of mobility and safety, it kind of brought it all together for us on how we're going to describe it. So our next, how we want to try to implement this is developing these WSIs as our new tracker measures and being able to show for a season long and or if we want to go for a particular event, what was the severity of that event? Was it below average or above average for our operational costs, for safety costs, and for mobility cost? So that's where Dr. Yao and I are with it right now. We've got all this data that's being brought into the Titan app. And now we're trying to organize it all and put it into a way that we can display it to our leadership and our exec team, and also a tool for our building supervisors and our district maintenance engineers to also use this in a way that we can be not so much reactive, but also proactive as well. The event that Dr. Yao illustrated there that we had at the end of November when we had the Kansas City Chiefs game and the Mizzou Tiger game, yes, there were a couple buildings that had pretty high WSIs for mobility and for safety. And those help us kind of going after the storm of what happened in those districts or what happened in those buildings. So we can pull up that dashboard and see what buildings are red for any one of the matrix and kind of evaluate, well, what happened? Was it something that we could have been more proactive for going forward? Or like this, it's a one-time event where you've got a major football game and a major college game all happening at the same time. And there's really not too much that we could have done on avoiding that congestion for that particular storm. So that helps us in saying, okay, we'll see what the severity was. Was it greater than normal or greater than average or less than average? So it's going to help us be able to identify going forward. There was another storm last year in February that went along I-70 that Dr. Yao and I have analyzed quite a bit too. And this storm shut down I-70 for almost 36 hours. There was a 20-mile section on I-70 where we had 2 inches per hour rates and a couple tractor trailers got sideways that closed the route. We couldn't get out in front of those tractor trailers that had the road blocked. And so our trucks were deadlocked in the queues. And the side roads all started getting deadlocked. And we were able to look at that, and after action items that we were able to take from looking at this helped us going forward on that section of I-70. Now we're assigning more resources to that section of I-70. There's a particular hill that's got 3 climbing lanes on that hill that's particularly troublesome for tractor trailers to begin with. And so it kind of drew more attention to us on this is something that we're going to have to dedicate more resources to this section of I-70 in particular, and have done that going forward. And the couple storms that we've had this season, we've been able to mobilize strike teams to make sure that we've got that particular section of I-70 covered. And so that's how we're using this app and the dashboards for kind of summarizing a season or summarizing an event after it happens to see what its severity was, but also using this information as a learning tool to be proactive for the next storm and what we could have learned from it going forward. So with that, Deepak and Jeremy, I think that's all we got, unless there's any questions.